In this video, I'm going to introduce the join in SQL, which is essentially a way to merge data between one or more tables. And then I'm going to also cover primary keys and foreign keys, what's the distinction, what they represent, and why they're useful. And then also just how to test uniqueness of values within a query, which we already know how to do, but just want to point it out that it's important to test or recognize when using certain fields as joining criteria or what values you're ultimately matching between for the data merge. And then we'll also talk about the different join types or merge types, which isn't really unique to SQL. SQL obviously has its own syntax or calls them by a certain name, but this really is a kind of a feature of joining data that exists for all programming languages I'm aware of. That support this kind of merging and that sort of thing. So jumping into the lecture, we'll first cover primary keys and foreign keys. As I said, a join is a table merge. So we're basically putting together horizontally to data from one or more tables, right? So this is different from like a vertical stack. We're really joining the record level information across one or more tables. And so usually, I'm not going to say that this is always the case, but usually those fields that you're matching on are some kind of primary key or a foreign key. What is a key, right? That's usually a way to uniquely identify a record. So a primary key is one field or a combination of fields that uniquely identify every record in a table. So if we were to look at the example on the right for the address table in the person schema, and this also tells you how to access this information under the columns node, under the table node, we'll see that we have the list of columns that are actually in the table, and then some information in parentheses about them. So you'll see in these fields here, there's, I don't know, 9 fields. You'll see that there are designations for PK, which is your primary key, and FK, which is a foreign key, and I'll discuss that in a second. You also see information around the data type of the field. So we know that address ID is an integer data type field, and it's also does not, I can't recall what not null means. I don't know if it, I think that means that it can't accept null values in that field. I want to say I'm 99% sure on that, because you'll also see address line 2 has a null here. It will accept null values. And if you recall, a lot of times that field wasn't necessarily populated in that table. At any rate, the important part here is being able to recognize your PK and your FK or foreign key, primary key. You also notice the key icons, right? So the black one kind of pointing to the left if you're looking at it. That is a primary key icon, and then your foreign key is the kind of empty, the outlined key pointing to the right. And that's essentially saying that it can link to a primary key in another table. So talking about the foreign key designation, really that's just a way to tell you that the foreign key is a primary key in another table. So it is ultimately a way that you can link your data. So I know, for example, if I'm working in the address table in the person schema, that I can pull in information related to state province ID from another table. And that table happens to be the state province table in the person schema. And this is a way to actually associate that ID with a state or province name, right? And we'll have some examples on that in other lectures. But at any rate, these are kind of the ways that all these tables are linked, or these keys, and this is kind of the basis or the framework for a relational database management system. I also want to point out or introduce the concept of indexing. So keys are indexed fields, which means that they're kind of, I'm not a computer scientist, so I'm not going to get the technical details right. But essentially, SQL recognizes all the unique values for that particular field, and can process information or process queries that are based on that an indexed field more quickly. And so primary keys and foreign keys are always indexed, so that allows a join to be efficient. There are also benefits to indexes outside of merging. For example, if you've got very, very large data sets, very, very taxing queries, sometimes some of the information that you're searching, especially if it's a modification of a value in a field, is best to index based on that kind of modification, so that SQL already has it kind of already anticipates what that's going to be, rather than processing it as part of the query plan, which can introduce additional costs that you can avoid with an index. And so that is really the primary key, foreign key introduction. Having introduced that and knowing what they are and that sort of thing, I will say that I have never looked at a primary key or foreign key in the 6 years I've been working with SQL almost on a daily basis in my job. And that's because going back to primary, the first lecture on the primary key, right, or the first slide, the keys aren't necessarily limited to one column. So, right, you can look in there and at the way that the table is designed and figure this out. And the other caveat there, and I don't personally know because I don't know enough about DBA, database creation management. I don't know that these keys are always set up correctly. I really don't know. It just might be simply they pick some fields that will allow you to uniquely identify a record, but that might not necessarily indicate whether, that might not necessarily be useful for the information you want to join on. So in practice, it's always best to not assume a particular field that you're using in a join has unique values. I think most people like to dive in, to merge the data immediately, but this can cause issues, which I'll cover in a separate lecture, around duplicate records, right? If you have a one-to-many or a many-to-one match, depending on how your join is set up, you can ultimately duplicate records, which is an issue, right? If you're doing analysis and you don't realize that you've done it, because you're going to double count certain records depending on the analysis that you're requesting. So we know how to do this already. We know how to look for unique values, test unique values using a group by and a having clause. So in the first example, we're looking at the address table in the person schema. We're requesting SQL to return a count of records for each value of address ID. And because we're doing that for each value of address ID that is in our grouping criteria, we're going to group the results or the query by values of address ID. We're only going to return those that have a count greater than 1. So what does that mean? That means that address ID would appear in more than one record within the table source, which could be an issue if you're joining on that field. We see that it returns 0 records, meaning that address ID is only comprised of unique values, at least at the time this query was run. That's another important thing to remember, is that a table in SQL can always be updated at some point in the future. And if we hop over to the second query, we can see in this particular table, product inventory in the production schema, we're requesting count by values for product ID. Note that, when a field is called ID, you would kind of expect it to have unique values. That's not necessarily the case. And so when we run this query and return values for product ID that have more than one record, we immediately see that we have, for example, in the table source, we have 3 records that have a value of 1 for product ID, another 3 records that have a value of 2 for product ID, etc. So I'm going to hop over to SQL Server Management Studio and replicate this quickly. So I've already got it set up, my database set up. We did ultimately run this, right? This query and noted that there were no non-unique values for address ID. And I believe, let me check the PowerPoint real quick. I can't remember what table we were looking at. Yes, so we were looking at this address table, same one that we ran the query on, and we know that address ID is the primary key for that table. And there's only one column, so this field is going to be comprised of unique values. When we go over here, right, to this other query where we're counting records for distinct values of product ID in the product inventory table, you can see that we get quite a few records that have more than one record in the table source for a particular value of product ID. So the question is, well, what is that primary key for that table? It turns out it's a combination of fields. And so if we go into tables and go down to the production schema, once that loads, and I'll expand this out, we'll go to the production product inventory table. And you'll see we have various information here. This would show you the various things that are indexed in the table. There are also triggers, which I'm not going to talk about here. Keys, these are the various keys, right? We'll also see that set up in another, not set up, but we'll see it in a different format with the columns. I like looking at the columns, right? Because that lets me know it's a little bit more explicit what is the primary key, the foreign key. These keys are set up, they're named nicely in AdventureWorks. I'm not sure whether that would be the case in practice, right? But we can see that our primary key for this particular table is fields product ID and location ID. So what does that mean? When you look at the record level values, combination of values for product ID and location ID, those combinations are going to be unique for every record. There aren't going to be more than, you're not going to have a 1 here, a 1 here, and then that same thing in another record. That won't occur. So the combination of values across those fields are unique. You can see, right, the primary key is named in such a way that it's telling you, okay, this is the product inventory table, product ID and location ID are primary keys. It also tells you a little bit about other foreign keys. I'm not going to talk about it too much, but you can notice that product ID and location ID are primary keys, or the primary key for this table, and then there are also foreign keys in other tables. So going back to the lecture, we're going to now move into different join types, and these might not also always be. I got to switch that around. These might not also, these might not always be the names that are used when talking about joins in other programming languages. But for SQL, there's essentially two different types of joins, an inner and an outer join. And I'll just start there. So an inner join is really a join that only returns records when there is a match across the tables that you're joining on. And so if the value appears in one table, it doesn't appear in another, it's not going to appear in your results. So an inner join, the values must be matched in order to be returned in the output. The outer join is the opposite. So some are all unmatched records are returned, depending on the type of outer join. So there are three types of outer join. There's a left, a right, and a full join. And basically, those different join types determine in which cases an unmatched record is returned. And also depending on which table doesn't have the match, or which table actually has the value, however you want to think about that. And so I've introduced the inner and outer join types, but in practice, I think of it as there are four different types of joins, right? There's a inner join, there's a full join, there's a left join, and there's a right join. Three of those, the full, the left, and the right, happen to be outer joins, so that they return unmatched records. And so building out like the full nomenclature for these join types, we have for the inner join type, it's just called an inner join. There really is no shorthand. I shouldn't say that because I believe if you just type in join, I like to be explicit with my syntax. So I don't really want to go down that path. I always just say inner join when I actually type it out in a query. The outer for a full join, a full outer join is the full description. I always remove the outer reference and just call it a full join. Same with a left outer join and a right outer join. But just recognize that when I say full left right, those are outer joins. There is no such thing as an inner join for a full join, a left join, or a right join. So it's kind of implied, right? You can type out these full values in a SQL query. There's no risk to doing that, but I always rely on the shorthand. So that's what you're going to see going forward. And then talking more about the difference between this inner and outer, and then the different outer join types. So talking through the full versus inner join. So these are really the two complements or counterparts to one another. An inner join only returns records that are matched, and a full join is going to return all records regardless if there's a match in the other table. So to work through examples, right, you have in two tables, right, that you're going to merge together. There's a value that you're merging on, which is represented by this column here, and it can appear in one or both of those tables, right? So in the first example, the value 1, which is what we're going to match on, is in the left table. It's also in the right table, what's referred to as the left and right table, which means it's always going to be returned by an inner join because it appears in both tables. It's also going to be returned in an outer join because the outer join is going to return it regardless if there's a match. Now, where there's a distinction or a difference is when the value appears in one table and doesn't appear in the other. So with the value 2 here, it appears in the table left table. It doesn't appear in the right table, and inner join won't return it, right, because there isn't a match. But a full join will return it. And what is going to be displayed for the fields from the table where the value does not appear is going to be null values. Essentially, it's missing, right? So it appears in this table, it's missing from the other one. We're going to display it in the output, but where it's missing, we're going to have null values. And then the same thing happens if you're talking about a left and right table. Same thing happens if it's not in the other. If the value appears in the other table but not in the first table. And so in that example, right, the inner join won't return it. There's no match across the table, so full join is always going to return it. And so the only difference where this comes into play, right, if it's in one table versus the other table, when there's not a match, is really when you specify a left or a right join, which we're going to move into now. Essentially, you need to think of, right, I've been talking about a left and a right table, so let's just look at an example written out, right? So in this particular query, we have a join, right? And so a join appears in your from clause. We have from left table. So this would be your standard query from clause. You're going to have from a specific table. Then you're going to have a join type followed by another table name. And so given the order that you put these in your from clause, right, the first table is always going to be your left table, and then what follows the join type is always your right table. Okay, so if I was looking at this, right, I can see left table is on my left, right table is on my right. And so that's important to remember when we actually go to using a left or a right join. A left join, right, is going to return all records from the left table, regardless if there's a match in the right table. And the opposite is true of a right join. It will return all records from the right table, regardless if there's a match in the left table. And the one thing to note is that there really is no need for both a left and a right join. It's convenient to have them, right? If you need to switch to join type, you don't really have to do a lot to change your query, but just recognize that all left joins can be written as right joins and vice versa if you switch the order right in your from clause. And then you might also need to switch your table aliases, which we'll talk about in a separate lecture. But just recognize that, right, in this example, from table A, left join table B is saying we're going to return all records from table A, regardless if there's a match in table B. That is equivalent to from table B, write join table A, because in this example, we're going to return all records again from table A, regardless if there's a match in table B. So it's important to recognize you can write them both ways, but it's ultimately, I guess, most important to recognize which one's the left table, which one's the right one, which one's going to have all records displayed, regardless if there's a match. And so that really concludes this lecture that covered primary keys, foreign keys, how to test for unique values, and then the various join types.